Hi everyone. We are at NET-136 OS2, our Linux work, and this is week 4. We meet every Friday. So we talked about the outlines. Students need to be working on the outlines. Students need to finish up Lab 3, and we went through an example in class. We reviewed the curriculum a little bit. And we talked about the difference between just getting things done and actually preparing and learning the material they need to learn. And then we talked about connectivity today. We were going to work on getting connected, adding a user, secured connection, and so forth. So create a user, SSH, static IP, in the servers. So the day went really well. We talked about classwork 1. We went through a number of things. You can check the review video for weeks 1 through 3. Has that material. And today then we covered some key things that have to do with setting up SSH and static IPs within the servers. In the first chapter, we did a little review of the first chapter. They talked about Android. We talked about the difference between a beta or a stable version, and then the different distributions and so forth. And maintenance cycles, how important, when you know how long the maintenance cycle is going to be, whether you use a version like that for a server. If maintenance cycle for a year, then you don't have to worry about updates for a year unless there's a specific update that it needs. That's one of the problems with a open source software like Linux, is keeping up with the updates. All right. We talked about remote access. SSH, how to enable that. Connect, talked about connect to a domain name or an address. And that address has to be static, so you can distribute the address and people can use it. We had these addresses here, so we assigned them to the servers, and then I gave them the default gateway. View the current configuration. They should be able to view that. Route information, IP configuration. And they needed to create secure access to the machine. So they did the research. They had to create a user with a password so that the machines would be accessible from other Linux boxes or other machines they're in class. So they did the research, they did the work, and they document it. They should have created and document the work. And this all goes into the journal that each student should be accumulating, accumulating the work. So we had last week, we had all the things we did last week, and then this week we did this work on the servers. And then the last thing we talked about is we went back and we reviewed booting an operating system. We talked about firmware coming out of the ROM. We talked about Intel machines instead of BIOS. How they boot. The old Macs used open firmware. The new Apples now have Intel inside, and they are using this method of booting. We talked about how important it is when you schedule events in the computer. So we're trying to break that down a little bit more each week. So we talked about the kernel and the microkernel. We reviewed those. We talked about whether you're in user mode, kernel mode. When you're in a kernel mode, that gives you, sometimes called privileged system or supervisor, that gives you access to the hardware. Kernel mode. Actually, I would say access to resources. Access to resources. And we talked about, then we're going to talk more about scheduling next week, but to get to that point, we talked about interrupts, whether the software interrupts to do some hardware exceptions. So the machine can be processing, needs to write something out the disk or get something off the disk. That would be a slow process compared to how fast things are going in the machine. So you could start bringing that information to memory and then do a number of other tasks, and then you could get an interrupt a hardware interrupt that would say, okay, we're done loading that stuff. That other piece of software can now continue. We got software interrupts, the software program requests the hard drive. Then exceptions. Something causes an exception. We talked about like software in a car. You have a car. You have a car, and that's kind of an old boxy car. And you have a collision in the front. That car has software, has an OS that's making the whole car work. You get a collision, you get an exception. It says now the computer has to deflate the airbag. And it can't wait. You can't say, well, let's finish something else that we're doing. No, it has to do that right away. We talked about a process. And in general, we said either that process is running, or it's ready to run, or it's currently being blocked. We defined the difference between a process and a program. A process is in these states, ready to go. We talked a little bit about the stack, and we talked about multiple stacks where you can have threads, different spots in the stack that you can be executing. All right. This is a reminder the students should be working on their theory outlines too. And that is it.